Good morning and good day, everyone. My name is Tony. I'm a course advisor, and I will be your host for today. Please do indicate on the chat if you're able to hear me. Before we start, I'll just like to start with some housekeeping rules. So this is the notification and sound settings. So you are able to turn on and off the notification sound and notification sound as you please during this webinar. Please do post any questions under the Q&A function at the top right hand corner. You will see the Q&A, so you can just post the questions there. If it's general questions, we'll be able to assist that. But if it has to do with today's topic, our presenter for the day will be able to then assist regarding that. This is some of the frequently asked questions. So everyone registered for this webinar will receive a copy of the PDF slides and a link to the video recording within the next 2 business days via an email. So please do monitor your junk folder, spam folder, if the email does not appear in your inbox. Another thing is that we will also provide you with a free digital certificate of attendance for live attendees. There will be a link and a QR code to a short survey provided at the end of the session. So please do stay with us until the end of the session to qualify for the certificate of attendance. Event conduct. So please keep the discussion lawful and respectful. Follow the moderator's direction. Do not share illegal or abusive content. Recording is not permitted unless authorized. Breaches may lead to removal and referral under the ECT policies. Today's topic is from robotics to secure autonomous navigation, the role of AI and smart sensors. Our presenter for the day is Dr. Ali, he's a lecturer and a unit coordinator at EIT. Dr. Ali, can you hear me? Are you able to take control of the slides?
Hello,
Dr.
Tony.
Ali?
Yes, hello, Tony, and hello, everyone. Thank you so much for having me here tonight. Actually, today for you and tonight for me. And yes, I can hear you loud and clear.
Okay, I can hear and see you. You can just take control of the slides.
All right, thank you so much, everyone, for attending to this webinar about robotics to secure autonomous navigation, the role of AI and smart sensors. My name is Ali Marzougi, and I joined EIT since 2019 as a lead lecturer in EIT in different level of bachelor's, master's, and doctor of engineering. So today we are talking about autonomy and AI, and the role of AI in robotics. What is the robotics intelligence and robotics models, smart sensors, and sensing modulation. Then we move to AI and fusion, sensor fusion, safety and functional standards. We introduced some of them, and then some practical computing platforms and some case studies. And then you can ask your question at the end of the webinar. So let's start with introducing the autonomy and AI. There is a difference between automatic and autonomy. So autonomy emerged recently, and it's been quickly actually accelerated. So why is autonomy accelerating now? So first, start with the difference between the automatic and autonomous systems. So autonomous systems are systems that can make decisions in difficult situations. So they can make the best decision for finding the best solution. Automatic devices also do similar, but they have to be pre-planned in some cases. So they have some sort of pre-programmed. Actually, in autonomous devices, they act like human body. So in critical, in difficult, in complex situation, they can make the best decision to be able to perform safely and fast. So why autonomy accelerating? Because we have the, the improvement in computing, in sensors, and the emergence of AI in not like 10 years ago, because AI is not something new, especially in engineering. We had AI previously as well. So we had lots of AI applied in different devices and equipment. However, nowadays, the application of AI and the capability of AI has been improved a lot. So previously, the AI used to be highly narrowed. Um, 10 years ago, if you want to develop an algorithm for path planning for mobile robots, there are lots of complex mathematics involved. Those mathematics involved currently as well, but AI can handle all of them pretty easier. So we have very smart sensors. So we talk about the smart sensors later on. Actually, we've already talked about that in another webinar. You can go through EIT website and watch the webinar about smart sensors. Um, so the sensors have been smart now. So they are not just um, data gathering devices, same as what they've been few years ago. So they can do some process on the signals, which makes the procedure faster and highly reliable. So we have AI as well. So AI today is not only the AI same as what we had in 10 years ago. Actually, AI today is capable of extracting context rather than just working with some nonsense numerical values. So they can extract the context and semantic and make the best decision. We are going forward and we talk about each of them. So how help they help to the process to be low cost, to be faster, and to be more reliable. That's why autonomy is accelerating these days. So look at this um, trend. So it shows you the difference between automation and autonomy. Actually, we had industrial automation. Actually, we have industrial automation now as well. But it's been highly engaged with AI now. So we call it as industrial autonomy. So previously it was the system was semi-automated, and then it's been fully automated, which increased the productivity and safety of the equipment. But currently we have autonomous operation, which is optimized version of the autonomous devices. So if we want to say AI, what is AI? The first thing that comes to our mind these days is some general AI, such as GPTs. So we have ChatGPT and we have cloud and we have multiple other variation of AI that are working based on learning language models. So we have large language models, LLMs, or small language models, which is SLMs and so on. So when we are talking about AI, people automatically think of that sort of AI. But the question is, if the AI which we are using in engineering is the same as AI that you are using on your computer while you want to um, write a letter or organize your meeting, or using AI agents in your computer for developing some documentation. So, no, definitely not. Because the difference between the AI, general AI, which we are using in daily based job, so for example, the chat GPT, which is the most famous one, or cloud. Definitely, if you try them, you could see that they make some mistakes, they get confused, they give you some incorrect responses. But the question come arises, are they really responsible for what they are doing? And if they make some mistakes, are these mistakes that much critical or results in some catastrophe? No, definitely not. But in engineering, AI deals with physical properties, with physics. So when we are talking about AI in robotics, AI in autonomous vehicles, AI in drones, if AI makes any tiny mistakes in decision making, for example, while an autonomous car is driving in the street and AI makes mistakes on mapping or detecting an obstacle, which is a dynamic obstacle, what would be happen? So it cannot come back to you and say, "Oh my God, I'm so sorry. That's mistake. You're right." And whatever words that ChatGPT use normally, it results in a catastrophe, right? So in engineering AI, we interacting with the physical world, and that's why it must be highly reliable. 0% of mistakes is acceptable for engineering AI. So that's the difference. Actually, you can see that we have different types of AI. For example, we have artificial superintelligence, which is the future trends of AI, not currently developed that much. So it's been um, under development. So this is some sort of philosophical AI, which can think exactly like a human, right? But the AI in engineering, such as all learning-based algorithm, they must reduce the error to almost zero. 0% error is acceptable for engineering AI. So in case of the robotics intelligence and models, we have different definition of intelligence in robotics currently, which we call it as embodied intelligence. So what is the meaning of embodied intelligence? Embodied intelligence means intelligence that exists inside a body, interacting with the real world. Same as me, same as you, same as all of us. So in the case of embodied intelligence, there is a loop that always must sense, then think, then act. So we have three active um, procedures. So we have sense. So data has been captured, must be transferred, and then the AI or the embodied intelligence must think of that in very short, tiny time, and then they must make a decision and act according to what they've received. So this is a continuous process. It's continuous process. It includes lots of uncertainties, and there are safety critical safety matters, right? So embodied AI includes the AI agents that interact with the learn from a physical environment. So before we are moving forward, I remember I forgot the name of the gentleman who said that, but the future of the engineering is with some engineers who are better to work with AI agents. It applies to all different types of AI. So if we are in engineering field, AI agents means all the robots, the devices, the AGVs, and all the AI-based equipment that you are dealing with. In physical environment, we are dealing with a very noisy environment. So a dynamic environment is not some sort of a limited, highly limited, noise-free environment, which is pure and clean and ready for you to work. So the AI that makes this decision must be able to filter all these noises and reject all the disturbances and make the best decision based on data has been provided. So in this case, we have foundation models for robotics. What is the meaning of foundation models of robotics? Previously, a robot has been developed for doing a certain job, right? So, for example, you had a arm robot for picking and placing. So it's been pre-planned and pre-programmed for just a certain job. So every dynamic of the robot has been designed and developed for these specific tasks. But currently we have foundation model for the robots. It means that while a robot has been developed, then it can do multiple tasks. So it's not just developing for doing a certain tasks. Same as human body. So we are multitaskers, right? So if we want to summarize the robotics intelligence and embodied intelligence, which is some sort of robotics intelligence nowadays, we can say that intelligence is inside a body, it interacts with the physical environment, with all considering all the noises and disturbances and dynamics. So the embodied intelligence must sense, think, and act in a loop in this uncertain world. So it must be able to handle all the disturbances while it takes care of safety, not for 90% of the safety, not for 95% of the safety, but almost 100% of the safety. We have smart sensors and sensing modulation then. So smart sensors helped a lot in case of developing the embodied intelligence. Why? Because previously the sensors that was Only some sort of devices that could detect some signals. It could be different types of signals, such as thermal signals, such as hydraulic signals, such as electrical signals. And regardless of the magnitude of the signals or the noise carried by the signals, these signals would be just transferred to the main processor, and then the rest of the processing, data processing and signal processing have been done on the processor somewhere else, somewhere in a cloud-based environment or in some special servers or computers or so. But currently, we are dealing with some sort of sensors which has a built-in processor. So these built-in processors help the sensors to be able to do some uh, process, at least some primary process. For example, they are capable of amplifying the signal. So for transmitting the signal, what do you need? For example, you need 4 to 20 milliamp signal to be transferred, right? Or you need 0 to 10 volts signal to be transferred. And while the signal that you detect is 5 millivolts, so it's a very tiny signal, including lots of noises carried with the signal. So previously, it must be transferred as it is. So it increased the rate of failure. But currently, while it's been detected by the sensor can filter it on spot, denoise the signal, and then amplify the magnitude of the signal. So the signal reaches some level between 0 to 10 volts, for example, right? And then transfer this clean signal. So you can see the difference. There is a huge differences between previous and current form of the sensors. Some of the sensors can even add some other values to the signal. So you have an analog signal, for example, you have 4 to 20 milliamp signal, which carries just some interpretation of, say, for example, temperature, right? But the smart sensors currently can add some other information to these sensors, for example, the calibration information of the devices. For example, the tag number to the signal. So while these signal transfer and received by another server or computer, then it has lots of information on this. So that's the art has been used in smart sensors today. And these smart sensors can do the job on the spot. So we call it as edge computing. So we can say that the smart sensors create some capability of or enables the edge intelligence. Edge intelligence. It means that each sensor has some sort of intelligence in it, embedded in it, right? So that's the meaning of smart sensors, which revolutionized the current technology of the AI and robotics. So we have not only one sensor applied in one autonomous system, such as an autonomous car in the image that you can see, or a robot or a humanoid, or a drone, which is fully automated, right? Fully autonomous, actually. Why? Okay, let me tell you a story. Previously, while you design a drone, and this drone wanted to plan a path, right? So find some object somewhere. or avoid an obstacle. So you used one sensor, for example, a LiDAR sensor, which is a very strong, very good sensor, or you used a GNSS system. So, for example, using GPS, right? Or IMU. But imagine that if a drone is equipped only with GNSS and then it goes through a tunnel or some area, for example, if it goes to Sydney CBD, like flying between these high-rise buildings. You have blind spot of the GNSS, right? So what would be happen? While it cannot receive any information about GPS. What it can do? It's been lost. So it's a failure, right? But currently we have multiple sensors because each of these sensors has some advantages and or they have some strength and shortcomings. For example, you have camera, which provides you a very precise texture of the environment. For example, RGB plus stereo cameras. So it gives you a rich semantic data in general. You have LiDAR, which gives you a very accurate information about the obstacles, about the objects. You have radar, which can work in harsh environment, right? We have IMUs, actually inertial measurement units, which has been equipped with the gyroscopes and magnetic sensors, and they can find you the best pathway for flying or for driving, right? And you have GNSS, which gives you a very accurate, very precise information, um, which comes real time, right? So it gives you information about the global position of the current device, if this is a vehicle or if this is a drone or any other robotic equipment. But they have some shortcomings as well. For example, for the cameras, if there is something wrong with the lightings, so the image that has been captured is blurry, so it cannot give you sufficient information. Or in case of the LiDAR, if the object is transparent, so the LiDAR cannot detect it properly. Or in case of the radar, if the object is very tiny object, so it cannot be detected by the radar, right? However, it's very strong sensor in case, and it's very fast. It can detect the high speed motion, but if the object is not that much visible, so it can cause some issues for that. So we have IMUs and GNSS, again the same. So for IMUs, we have highly accurate in global positioning, but unfortunately, we have lots of drifts over the time. And for GNSS, we have blind spots as well. So what we have to do then, and another sensor that we this is not it's not been commercialized yet, as far as I know. So it is under development, but in laboratory scale, they are working with some research in some research area, which we call it as event cameras. Event cameras also are very highly reliable cameras and very accurate. So they have very low latency. because they are not same as the general cameras, which captures the whole image at the same at one time. They are looking at each pixel as an event, and they detect the change of the density of the light in the pixels. So they detect the change of density of the light in each pixel. So it gives you a highly reliable and fast and accurate um, image. But all of them, if they've been used separately, individually, in a robotic um, device, in a drone, in autonomous vehicle, in humanoid, they face with failure issues. So what we have to do for optimizing, for avoiding this problem, we need to we need to use multiple sensors in a device and then fuse all these data with each other. So a single sensor is not using in any autonomous device. Rather, we are using multiple sensors. For example, we use LiDAR, IMU, and camera for localization and mapping and path planning to increase the reliability and decrease the error to almost zero. So how it can be done? By fusing this information, by fusing these data. So what would be happen here? You have LiDAR, you have IMU, you have camera, for example, in a robot, right? Imagine that for some special reason, we have camera failure. For example, light intensity would be changed, and then the image captured by the camera is blurry. So you cannot rely on that image. It's failed. However, the camera failed, but you have two other options still, including IMU and LiDAR, that are highly reliable. And in sensor fusion, in the algorithm, um, in sensor fusion, they make decision based on the best information they received, right? So if two of them has been failed, for example, camera captures um, blurry images and IMU drifts, still you have LiDAR, right? So it can detect the objects and gather the information, transfer this information for further processing and for global mapping and local mapping and so on. So we have sensor fusion procedure for increasing the reliability and reducing for reducing the error to almost zero, right? Then we have some frameworks which actually are using currently. They are open source frameworks and they are highly reliable. They called as fast Live 2, R3 Live Plus Plus, or Slam 3. So normally Slam means simultaneous localization and mapping for mapping using in the mobile robots, ground robots, or aerial drones, or underwater drones for all of them. So these frameworks can fuse multiple sensors information, right? So you gather data from 4 sensors, 5 sensors, 10 sensors, or n number of sensors, and then they've been fused, and the best data has been extracted for decision-making purposes. So we talked about the smart sensors, we talked about AI, we talked about fusion, sensor fusion, and consequently data fusion. But what is the relationship between AI and fusion? So how AI helps the fusion to be improved or the fusion process to be improved? Is a fusion um, like recently developed, same as AI? We can say no, because previously also we had sensor fusion as well. And these sensor fusion work based on some mathematical algorithm, for example, Kalman filtering or extended Kalman filtering. So normally computation of this process is very um, timely and it's not that much fast. It wouldn't be actually. But currently, with AI help, with AI aid, it makes the fusion smarter. And it's not like only AI helps the fusion, but fusion also makes AI safer. So there is a reciprocal relationship between the AI and sensor fusion for localization and mapping in the mobile robotics. So we have hybrid systems. In this case, we have classical algorithm for fusion plus um, deep features, learning process, classical filtering plus a modern AI algorithm. So we have understanding of the semantic and geometry rather than only detecting some information about the geometry. Some or some numerical data based decision making. So we have understanding, we have perception. AI provides meaning, um, like it can interpret, it can interpret the event, same as what we interpret in our brain, right? So there are AI plus fusion, which results in safe intelligence. What does it mean? It means that only intelligence, embodied intelligence, or whatever intelligence that we call it, is not sufficient enough. So we need this intelligence to be safe for the safest decision making ever, right? And AI plus fusion can help us to increase these reliability and safety purposes. So that's how they are interacting with each other and improve the accuracy and robustness of planning, mapping, and path planning and global mapping for the autonomous devices. So in autonomy, we have currently, while we have AI plus fusion, we have a term that we call it as or a plan for optimization. How it achieves, um, actually, we have perception, localization, planning, and then motion control. What is the meaning of perception? It means that AI helps the robots to understand the differences between the objects. For example, previously, 10 years ago, 15 years ago, before AI emerged like what we have today, um, while a robot detects a human, it sees that as only an object. We call it as human, right? But currently, when an AI-based system in the robots detects an object and understand that this is a human, so it can understand that this object who is called human can have some unpredictable behavior. For example, while an autonomous car driving through the street and it detects a human in the pedestrian, it expects that with some probability, this human possibly may jump across the street without any alarming, right? Or prior notification. That's how you think. That's how I think. That's how we as humans think. So we don't see the objects just as an object, a solid object. We see the object with some meaning behind them. So the AI and fusion get together and understand these concepts. So currently we can see that while the autonomous car driving and see lots of people, dynamic obstacles moving around, it has some degree of expectation that maybe one of them, two of them, or some of them jumps across the street. And if it happens, what is the solution to that? What decision must be made? So this is a plan. It's planning for the next step decision making. That's how they control the motion. It's not just controlling the motion by say, all right, go straight, turn left, turn right, and if you see an object, dynamic obstacles, just avoid that like this. No, it's not like this. This is about perception and then localization and planning for the next activity or motion planning, right? So it happens in the drones, it happens in the autonomous vehicles, it happens in underwater drones, and so on. So what do we have is perception with foundation models. So we talked about foundation models, foundation robots are some sort of robots that can act in different tasks. So they are not designed for a certain task, but they can use for multiple tasks. How it can be happen? Because they have some sort of perception. So they can understand the story behind the objects. So what does it do? Enhance the decision making procedure. So optimize the decision making procedure. We call it as intelligent decision making for localization robustness. So how it happens? By fusing the sensors, by fusing data gathered, collected with different sensors to find out the best, the cleanest, and the most reliable data for planning the future behavior, which is the very um, close future. And then planning with AI and optimization. So in classical um, planning, path planning, and search, we use normally model predictive control plus AI. But currently, AI provides guidance because AI has been developed a lot. So um, the old classical version of AI is totally different with the AI that we are dealing with today. So the AI that we are dealing with today can understand not only the numerical values, but it can understand the context. It can understand the story behind the objects. So we have some standards that must be applied. In the robotics, actually, we have ISO 26262, which defines the functional safety for the road vehicles. So it forces a semantic hazard analysis. So that's what I told you. So while we have embodied intelligence, which has perception, so it must make sure that ISO 26262 has been met. We have for the safety, for reducing the error to zero, and we have ISO 21448, or we call it as SOTIF, which goes further. So it's been developed for handles unknown known unknowns, right? So it handles known unknowns. So unexpected behavior of the objects or unexpected behavior of any physical property which has been involved in the environment that the robots, either drones, aerial drones, or underwater drones, or autonomous vehicle is moving towards through that environment. And we have other standards. So if you are interested, you can go through and search for that, or you can send an email for further information. Another improvement is improvement in the hardware. Right? So we talked about edge computing. We talked about smart sensors that can make decision on the spot. But it's not only about the sensors, because not all the sensors are capable to be as smart as required. They must transfer some signals. However, they are pre-processing the signal, for example, denoising or amplifying the signal or adding some information. But for making the critical decision, we need a stronger processor. It happens by edge processing devices. So in the drones or in autonomous cars, it's not like data has been captured and transferred to a cloud, to huge servers, and then their decision would be made and transferred back to the car, to the autonomous vehicle, to the drone. Decision must be made on the spot in microseconds. That's why we have development of hardware. So we have Raspberry Pi 5, which is useful for some sort of research-based application, even for practical application as well, but not very complex application. But we have Jetson, which can handle sensor fusion, highly complex sensor fusion processes. So we have this development help us to be able to go through edge processing and edge computing, which is another revolutionized has happened to the robotic industry. So what you can see is the city scale autonomous driving by Waymo. Maybe some of you are familiar with. In different countries also we have these kind of autonomous taxis. In China also, I think I've heard that in China there are autonomous actually fully autonomous cars, but they have drivers inside just for increasing the safety. But Waymo runs fully driverless cars, so they don't have any driver involved. In U.S. Cities, in different cities in the United States, in Phoenix, in Austin, in Los Angeles, in that crowd, with lots of obstacles, with lots of unpredictable behavior of the human. So they run for Um, I don't know how many kilometers, how long, but they have almost negligible accident happen. So, and all because of these technologies of sensor fusion, edge computing, and AI involved. So another example is we've lost drone. We've lost drone delivery zip line, which delivers the critical medical supplies in United States, in Africa, in some part of Africa, in the United States, normally for remote area, for example, for some area which is not accessible by human. And normally in that area, sometimes it happens that you have, for example, GNSS blind spot. So that's where sensor fusion works perfectly. So you have no failure in delivering these critical medical supplies to the environment. However, the environment may be harsh. And then because they delivered some critical medical supplies, they may subjected to some signal jamming, for example. So they can rely on other type of sensors. So they have sensor fusion and AI to help them to make the failure to be zero in real world physical environment with lots of noises, disturbances, and uncertainties. Also, in Amazon, we have lots of fully automated warehouses. They are equipped with humanoid. They are equipped with fully automated AGVs, automated guided vehicles. So actually, there are people working there, and not too much, just one or two technician in a huge scale warehouse, just for the safety purposes and for doing some technical job. Other than that, everything has been handled by the autonomous robots. While the environment is fully automated and lots of robots, they have to be able to detect each other. They have to be able to detect the objects, which one must be picked, which one must be palletized. So they have to be able to avoid obstacles which are dynamic obstacles without colliding with each other and so on. So all of them are because of the AI plus fusion and smart sensors, which helps the system works autonomously. So at the end of this webinar, we understood the emergence of current version of AI plus smart sensors plus hardware technology, which are the very strong microcontrollers and actually mini computers such as Jetstone, NVIDIA Jetstone, um, enabled through autonomy. So the foundation models of the robots, accelerating capability of doing the tasks, sensor fusion is necessary for a secure navigation. So sensor fusion increases safety and safety standards, which must be followed by the algorithm embedded into the robot. And definitely, the trend is embodied intelligent robots, which we have. Some of them are working in different industrial application and commercial applications, and it's been improve and improve and improve in the near future. So that's the end of this webinar. Actually, we have a special issue. If you have any interest on submitting if you have any manuscript about navigation, about AI, about sensor fusion. So you can submit this. Actually, the date says 15 March of 2026, but it's been extended. You have time until the end of September if you are interested to submit your paper. Thank you so much. And I hand it over to you. Tony, thank you so much. I appreciate for being patient with me.
Thank you very much, Dr. Ali. It was a very informative session. Yeah, thank you very much. So we are almost at the end of our session for the day. These are some of the Did I take control? Or let me take control. Sorry. Let me take control. And I would like just to thank Dr. Ali for this well-delivered lecture, as Samuel is saying on the chat. So these are some of the upcoming courses at ECT. So as you can see, we do have bachelor's, honors, and masters. And on the right-hand side is the start date for this year and next year, early February. So for more information, you can just visit our website, and our course advisor will then reach out to you. We also do have a professional certificate, which is a 3 months non-accredited program. It's a skills development course, basically. If you want to upskill yourself in a certain area within the engineering space, you can do so. It is delivered by the ECT's affiliated institute, EIT, Engineering Institute of Technology. You can go on our website. We have different professional certificate from different fields in the engineering space. And also there is a promotion that is currently running for a limited time. You can save up to 334 pounds on a 3 month online professional certificate delivered by ECT's affiliated institute, EIT. So you need to enroll by 30 November 2026 and pay only £599 instead of the usual fee of £933. So I'm going to be sharing the link now on the chat with everyone who will be then interested. Let me share it now. I've shared the link and the information about the promotion that is currently running on the chat box. So for the certificate of attendance, you can use your phone to scan the QR code. So please, the link does expire after 48 hours. So make sure that you do claim your certificate of attendance before that time. Let me see. There's about 2 minutes. There's about 2 minutes before the end of the session. And I'm assuming from the chat box being empty that no one really has questions. There's only Varesha that is asking, I would like to know about the payment method. I'll forward an email to you, Varesha, then we will take it from there. And I'll also like to share the link actually for the certificate of attendance. Let me share it now. There, Samuel, I've shared the link of the certificate of attendance. Any last words from you, Dr. Ali?
Thank you so much. Thank you, everyone. I appreciate that. Thank you. Thank you. No, nothing.
All right. Thank you, Dr. Ali. And thanks to all the attendees actually for taking their time to attend this session. So as I've said, I've shared the link to the webinar. Okay, I'll be sharing it again. Or what you can do, Varesha, you can scan the QR code. Let me just put it here on the screen. You can scan the QR code to claim it. Or I'll just check the link, then I'll resend it on the chat box. We are at the end of the session. And once again, thank you very much, Dr. Ali. It was a very informative session. And once more, thank you to all the attendees. And on the screen, these are our contact details. You can contact us from this information. Then our course advisor will then reach out to you in due time. We are at the end of the session, and we'll see you on the next one. You guys have a great day ahead. Thank you very much. Bye-bye. Dr. Ali, see you on the next one.
Thank you so much. Yes, definitely. Thank you so much. I appreciate it. Thank you. And good luck to all of you. Thank you, Tony, for providing this opportunity. Thank you so much. I appreciate that. Thank you.
Thank you. Bye-bye.